So this one, it began here, and then it decided that the place with the highest entropy is here, goes all the way over there, and then so on and so forth until it runs into the plume here. And then it samples all around it until it's minimized the entropy enough to move on, and then it starts going all around the area again. And it will, I mean, if it had the chance to run into this methane plume, then it would have done the same, but I cut it off before it found it. But then you can see here that it does interpolate the methane plume way better than the original did with just the Gaussian process. Okay, last but not least, the most exciting part. How many mathematicians or statisticians actually get to go into the field? So this is a picture that I took on my own cell phone of an orthocopter. If you can't tell, I was pretty excited about it. It was a little bit terrifying. It had like unprotected blades, which was semi-horrific. But then, so I didn't get to go on this field experiment, but they went out to Wyoming. I'm actually not sure specifically where it was. Someplace in Wyoming. And they were able to sample a methane plume at 3 different altitudes. So you can see here, this is where the orthocopter lifts off the ground, goes over here, it samples at this altitude, goes up to another altitude, samples again, and then a third, samples again. And you can see the values of the higher values of methane are in red, and the lower values are in green. And so then we apply our interpolation, and you can see. So we cut it off. We didn't show the plots for anything lower than 2 parts per million. This is just cut off 2 parts per million. But you can see the methane plume here, and then a scatter plot that shows the larger methane values on the inside of the plume. And then I actually have little videos that we made with MathLab that just give you a better view. So the red dots are the places that were sampled again. And then we have another one here. The visualization.
So cutting off the methane at some minimal level has the effect of making these little pieces look like they're truly separated from each other, but actually there will be probably a little bit not very dense methane heading between them.
Right,
But there's turbulence in the flow, and it will probably heat bubbles of it away eventually. So it's not completely unconceivable. It's just not normal plume, but then the turbulence takes over.
All right, so future work. We would like to consider more than one point at a time in maximum entropy sampling. So if you think back to my simulations for maximum entropy sampling, since I was considering each point individually, it resulted in a lot of jumping around in the methane field. Whereas if we consider subsamples at a time, then it will minimize some of that travel time to get to the places with the highest maximum entropy, and maybe a little bit better path planning. And then we would like to implement this maximum entropy sampling in the field. So we weren't actually able to implement it in the field. They just gathered it, like I said, at different altitudes, and we got to apply our Gaussian process model. And then lastly, to incorporate time in the model. So the samples that we took in the beginning might not affect our model farther along as we've been sampling more and more and more, because wind will change the values, perhaps the wind direction will change, and so on and so forth. So that is what I have. Here are my references. And then acknowledgements. I just wanted to thank David and Mark, because I gave them 2 weeks notice that I was going to pick up and move halfway across the country, and they've been very, very graceful about handling that. And then Dr. Raquelian as well, because I actually just met him for the first time yesterday, in person anyway, and he's been very, very wonderful via email as well. And then I was supported through the Lois Stokes Bridges to the Doctorate program throughout my master's, so without them I obviously couldn't do it. And then JPL's been wonderful as well. They gave me access to the lab as a visiting student researcher. So, other questions?
Let's thank Raquel for a very nice talk.